Fortunately, we have very cozy audience, not too big. So I'll be able to help you more if you have any specific question during the talk or after the talk. So welcome, all of you. I know there's a lot of talks happening, a lot of booths. So if you decided to come here, I'll make sure it's worth your time and attention, of course. Hello, everyone. My name is Sandeep Singh. I am head of applied AI at Beans.AI. And Beans.AI is a company which creates hyper-accurate maps. And these maps are used by logistic companies to deliver things more efficiently. And you can imagine these maps are so accurate, it exactly tells you where to park, after parking, where to walk inside the building, where is the entrance, where is the leasing office, where is swimming pool, and whole Minority Report, as you can imagine. So we are based in Palo Alto, California, and I take care of all things AI, machine learning, deep learning, and we have a global team across North America and Asia. Okay, before I talk about this slide, so how many of you have already generated at least few images by writing something? Okay, we have very active audience. And how many of you have ran some code to generate the image? Okay, few of you, great. And third and most important question, how many of you, regardless whether you are from the tech background or not a tech background, really understand the tech behind what's happening? Okay, at least we have few. So what I want at the end of 30 minutes, each one of you should know how this thing works. And that will give you idea how to choose tools available. There's a flood of tools happening, and how to do the quantitative measure of what's good enough, what's bullshit, and whatever. But I want you to really understand the process behind it, because what will happen, this process itself is changing, but a lot of people, when they release tool, they talk a lot of mumbo jumbo. And if you understand what I'm going to talk here, you'll be able to decipher what's useful and what's just the marketing stuff. So let's go. First of all, this is the term generative AI. We are significantly overusing nowadays. And everybody, as soon as you say generative AI, they think it's a chatbot. While in reality, what is happening, generative AI, this term will vanish in future, and the AI itself will become generative AI implicitly. So this landscape basically explains here that generative AI has a text, image, video, and the audio part. And that's where the term you might have heard nowadays, multimodality. It's nothing but saying your model works for more than one type of input. They use the term multimodality to sound it fancy. And these are the few of the companies you can see working in this domain. I'm sharing this slide just to signify that each dimension of generative AI is being developed at equally fancy space. And the innovation happening is mind-boggling. The rate at which tech is coming, products are not being able to catch up. So when somebody says generative AI, think chatbots, text-to-image, video, monitors, and everything. And we are going to talk about it. And just to get to, not to make you overwhelming about this slide, but I just wanted to share how much innovation has happened in last maybe 3 or 3.5 years. You see there's when the VAE encoder decoder came, it was a big deal, and there is a clip model I was talking a few minutes ago, Glide, DALL-E, Midjourney, Imagen, Stable Diffusion, and the GANs was the original grandfathers of generative AI. So you can see, as soon as you say the generative AI, everybody thinks chatbot, but in reality, there is a huge undercurrent being built for the information space where we'll fundamentally change how we use these technologies. So there's a lot of innovation happening, and hopefully by the end of this talk, you will understand, oh my God, it's whole domain. It's not just chatbot or not just text to image, and what's the interplay between them. So stable diffusion specifically, why should you care about stable diffusion? So in terms of how valuable this concept is, you remember, I know many of you are young, but I'm not so young. I remember when Java was released, there was a lot of excitement about the bytecode. The fundamental concept where compile once and run multiple times on any VM. And that was very pivotal moment in enterprise software. Similarly, what is happening, stable diffusion is at the center of a lot of things happening at the moment. For example, DALI 2, Imagine, and Stability.ai, stable diffusion, and many different companies like Runway ML and so on. Every single piece of innovation fundamentally is being driven by one thing, that is stable diffusion. So people release with new brands and tools and technology, but stable diffusion is that center idea which is causing everything, having a Cambrian explosion of innovation here. For example, this image, if you see, it's a generated image. I have generated myself. And the level of details which you see here is like pretty amazing. Okay, is this the one? Yeah. So if you see all these nuanced lighting and change in blur to more crispness, and then blur again at the water, this is something which only photographers used to generate. But now these models can do that. And stable diffusion is that technology which causes this innovation. So I'm going to explain to you how it works. And at the end of it, you might not know any specific library, but you'll be enabled enough to evaluate any library. Okay, a little bit of history of stable diffusion. In 2000, and stable diffusion is so young. It just started in 2022, which is like less than 18 months. Nobody was talking about stable diffusion before that. So 2022 was really the year of text to image. The basis of it started in 2021 when the clip model came, but actual products started coming in 2022. But the one thing you can see, OpenAI released DALI 2 in April. May, Google released Imagen because of the peer pressure. Midjourney came in July, and everything was closed source till now. So what is happening? While there was a lot of user excitement about these tools, and these tools are still more or less closed source mainly, but researchers and engineers like you and me were left high and dry, and people were excited, but they were not able to try things by themselves. And that is the moment when August 2022 happened. And Stability.ai spent around $600,000 to train their version 1 model. And after training that model, they released it to public with code and model and everything. And just to put in perspective how much flow of information in developer community it has created, you have to see this one. So these are like most prominent GitHub repositories happen. You can see there is a Ether, Bitcoin, Kafka, and Spark, and whatnot. And you see the vertical climb here, this is stable diffusion. So this is number of stars their repository got. So this is almost like a fireworks. You can see, right? And I got this chart from OpenCV's site. And this is pretty mind-boggling. Imagine, right, all the excitements here built over the years from like days, almost like 2,500 days, but this did in like 60 days. So this thing really matters. So if you are in development domain, this technology fundamentally matters to you, not just if you are in text-to-image domain or not. Because I'll explain you how this works, and you'll say, in hindsight, it looks like this idea is clear as daylight, but only we are able to do it now because of few things which happened in 2021, like Clip and other innovation, which we'll talk about. So August 2022, which is like 15 months from now, and that was the month when everything went open source. And you can say they got like 30K stars. Code was very simple, not very researchy, because what happens, a lot of labs, when they release the code, they make it so unintangible that they are as complex as their papers. And in a lot of cases, they are less useful than they should be. Main thing what happened with this open source release is that we can run these software on commodity softwares, like commodity software and hardware stack. Like you can just run it on your laptop, and simple GPUs, like they will work fine. Even a lot of code works in freely available Google Colab. We'll show you in a bit. Okay. So this and probably 2 more slides after this are the most important thing I want you to understand. You can forget everything what I said, but just understand here what is happening. So we have a text prompt. We take that text prompt and encode it into some form. And that form is some sort of latent representation. It's just the fancy way of saying it's a different number of vector of different length representing the same information. It's like mathematical way of saying we encoded into different form. Encoding is nothing but same information in different representation. We do that. And we perform this process called reverse diffusion on this using diffusion model. And we do it again and again. And eventually we emit one form which is like still in latent domain, and we decode that reverse diffusioned latent domain vector by decoder, and we generate the image. So what is happening here? Actual text which you enter doesn't get processed as it is. It gets encoded by some sort of encoder like clip and all. And we have some decoder which generates it like that. But what you have to understand, basically this whole image, basically it means this statement. It means altered noisy images looks like a little bit more like description as in text. So what does it mean? I just put it there, but don't worry about it. I'll show you next this thing. So this image I have generated myself, but this is just to give you an example. If you say generate an image of boy, right? And so what is wrong with this image? Obviously, the head and ears, that's not human kid. So the text boy doesn't match the head part. So which part it should change? Of course, head, ears, and that part needs to be changed. So what you'll do, you will go, if a human person is doing this, he will say, okay, boy, this image, let's change ear and head a little bit. And it will generate another image where head and ear will look more like boy. And then it will again see, is the head shape is correct or not, and so on. And then it will try to do a little bit more change. And then again generate the new image. So that process of seeing what was the text, what has been generated, and what needs to be changed in currently generated image. This process is called reverse diffusion. I'm giving few seconds just to understand. Reverse diffusion simply means what is the current noise in image, calculate that noise, remove that noise, and go again seeing what is the current noise level. So everybody understands this? This is very central to the current all fancy examples which we see on social media. So you see the text, you calculate the noise, you reduce the noise. Okay? So the text boy guides you to change ears. Right? So, and this is very abstraction, higher level example, but when we actually do the stable diffusion, this thing happens at the pixel levels. So depending on what is the concept in the text, it calculates what will be the noise at each pixel level. And that pixel level noise gets reduced, and this process goes again. And this, in the original paper, they call this step as time steps, how many steps you are removing noise from. And practically, that's the whole idea which has been implemented mathematically. And there are like few things which make it enable. We'll talk about it, but this is very important for you to understand. You don't just take the text and generate the image. You keep text as a guidance. to find what is the noise in current scale, and you keep doing it until it becomes good enough. Actually, currently the technology is about you do like 50 steps or 1,000 steps, pre-known steps, because your model was trained like that. So, and that's, you say, the output of. That is why what happens, sometimes you generate images on DALL-E and it's still not its great image, but still it returned it because it just did 1,000 or whatever steps and it returned to you. So that is the central idea. And next one. Okay, so I have already explained this slide. Let's review. So at every step of reverse diffusion, we want to calculate the noise on current image, remove the noise from the current image, and repeat it. And actually, the process will look something like this. This will be image. This will be network which will calculate the noise, and it will reduce the noise from this, and you'll get this. And this is actually what happens when you run your code. If you go step by step, not generate the whole image, you will see example like this going to this, or something like this. And this network here is a specific type of network which is used in medical images like unit. I'm sure many of you have heard, but it's basically, it's good at finding what should be the each pixel's noise level. It is used in segmentation type of jobs also, unit. It's basically a medical domain prodigy, but here it's used to calculate the noise and reduce the noise. And we do this process again and again. You eventually have a denoised image. And so the question which normally people ask, why don't you remove all the noise in one shot? Right? Because model doesn't know what one shot like noise looks like. It knows, it's like a guided machine where it sees something and it can tell little bit about it, not the whole thing about it. So that is why this process is called stable, because you do like slowly in baby steps. You generate little bit of noise, like calculate a little bit of noise and reduce it and go so on. So the two terminologies here you have to understand which people use to make it more fancy: latent and stable. So they call it latent stable diffusion. Latent basically means encoding into some other vector form, not the original text or image, whatever it was. And the stable means it's like you do like slowly. You don't do it one shot, right? Okay, so this is the actual process. Here, two parentheses, you see the orange color one. This is the training loop where you have the denoising network being trained. You show the image, you add the known amount of noise to it, and you give it to network. Network tries to predict some noise. Initially, when it's being trained, it won't know what amount of noise it is. But because we have added the noise ourselves explicitly, we know what noise it has. And that's how we train the network. So that is the loss function, is the actual amount of noise added versus what network predicted. You differentiate that and say, and you keep doing it until it becomes very good at predicting the noise. And once it's like trained to tell like how much noise image has, you do this blue parenthesis you see. This is the inference loop where you give the noisy image to network, and network does many iterations and gives you the real image. So this is the central idea. And this whole process, mathematically, the paper which came, it's called DDPM, Denoising Diffusion Probabilistic Model. And this is the link, probably they will share the presentation. You guys must go and check it out. But just understand that during training, you add noise explicitly and keep calculating the loss of predicted noise versus actual noise which you have added. And you keep training your network. Eventually, it becomes good enough so it will predict the noise at your input image. And that is the whole stable diffusion process. So when you say network has been trained, you basically means this guy has been trained enough so it can tell how much noise this particular image has at particular step, right? So just stare at it and try to make your mental map. Because when next time somebody talks about it, you'll be able to map your understanding here to what they talk. Okay, so here are a few examples. Actually, I don't have very good internet here, unfortunately. Otherwise, I would have shown demo on Firefly, but it's free to try. Go. If you see any type of example here, like these text, it will generate a robot's wrist wearing some band, photorealistic, whatever, or young boy reading a book, or red Indian young boy reading a book, very focused, happy, whatever. So what is wrong in this at the moment is that you will generate some robot, some boy, and some red Indian boy reading and some specific type of happiness. But you don't have much control here because these models are trained on a plethora of data, and this data is pretty generic. And a lot of time it has a bias of everything, because if you search for software developer, 80% time it shows Indian guy. So there is a simple bias, and bias is nothing but a reflection of society, but as a technical people, you have responsibility of not to amplify those biases and make it more generic. So what Dreambooth does, lets you customize these tools. So that's what the central idea of which we want to talk about. So you have less control over generation of images. Artifacts are hard to describe to achieve our concept in mind, and match something or somebody particular. For example, if I want to generate images of my dog, I can't do it. Like Tuffy jumping on the seacoast or whatever. We can't do that, and that's where the Dreambooth is your technology to go for. And this paper was pretty pivotal. Even if you're not a developer, I would suggest go to this link, download this paper, and just scroll all 27 pages. Don't do anything, don't read anything, just scroll it. And it has a lot of images like these, which will explain you what Dreambooth is. And the other thing is that if you work with a dev team or deep learning team, you can ask for these ideas. You can tell them, can you use Dreambooth to customize my product, my API, or you can do for your personal project. So basically it gives some sample image of subject, and they will give it some name. And you will ask that concept in some particular setting, like in Acropolis or in doghouse or bucket, sleeping, getting haircut. So you just gave it this, and all of the concepts it already understands, but this particular subject can be used in these generations. And that's what the Dreambooth's power is. It lets you dream. And that's why I've named my talk Custom Dream. You can customize what you're dreaming about. I highly encourage you to just go to this link and scroll all the pages. It's okay if you don't read a word, because it will educate you probably as much as this talk. Okay, so in simple words, Dreambooth can be used to put concepts in stable diffusion models by fine-tuning pre-trained stable diffusion model. First thing, this process is not as bulky as we read in social media. Like you don't need 10,000 GPUs, or for that matter, even 10 GPUs, one GPU is sufficient, and commodity GPU, which you get for free on Colab, or in Colab Pro, little better GPUs, that's sufficient to do this thing. So you should try the code. I'll share all the presentation anyway, so you guys can try it out. But here are some specific: creating personalized images of people, animals, objects, generating images of people in different scene, poses, and views, and creating arts of images for commercial purposes, and so on. So if you take a pause and think about it, basically you can do so many things. If you have a product manager in the room, you can really kill the developers with the feature requests, because you can just ask for so many things. The possibilities are unlimited. That is why we say it's a very exciting time to be in tech, because you don't really have to be AI engineer to use the AI. You can ask AI people to do it. And that's what is happening. The way we had database people, security people, and so on across the industry for more than 3 decades, we will have AI team as a separate standalone entity in every company. Like you cannot have a company where you say we don't have AI people. It's like saying we don't have a database in 2000. Like you cannot say that. So it's a fundamental, because it's a new information engine. So customization is the main product of Dreambooth. We are going to learn how to achieve fine-tuning of pre-trained stable diffusion model. It basically means if stability.ai or a Hugging Face has some model available, how you can take it and use your own images to make it understand the concept which you want. And I'm going to show one example here. So this is the actual image from the paper. What basically it does, you have your concept, which your pre-trained model doesn't understand. And if you give like a dog it will give some dog. But you don't want these dogs, you want this one. So what you do, in Dreambooth process, what you do, you generate a dog, and you calculate how different this dog is from this dog, and that is called the reconstruction loss. And that loss is used to adjust the weights in original model, and that's how we make it learn the new concept. So basically, you don't have to understand all the maths behind just to imbibe the concept. Basically, it means what you want to generate versus what it generated. You calculate the loss, and you use it as a loss function to do the adjustment in this network. So it will start understanding your concept. And you will give some custom name like VDog, and this is, I don't know why they use this name. They could have used something more sane, but V inside rectangle bracket, I don't want to name my dog like that. So, but that's what they used in paper. Okay, a little bit about naming your concept. So what happens, no matter what your name is, if you Google it, something will come up, right? And most probably, somebody very famous or prominent will be there which matches your name. So that is why when you're naming, suppose, if you're naming your dog Einstein, and you Google it, so model already understands a lot about Einstein, you should not be using that term. Maybe something, you can use something which is non-human readable, but it's very unique. And that's how you name your, for example, my neighbor's dog's name is Pickles. And I realized that if I have to train his dog's images for this one, it will be very hard because pickles is like common concept, like from cucumber to many other things. So you have to select the token or name a unique new thing for pre-trained model, the concept which it doesn't understand. Make the name long enough, at least 5+ character, otherwise it won't be able to get the gist of it. Whatever name you choose, go and try it out on the base model before fine-tuning. So whatever text you're trying to name your concept, just go and generate with that text and see what it does. Most probably it will do like something nonsense, but you will know that this concept is available to be trained, and it doesn't know this concept. For example, if I have to train images on my photos, and if I give the concept name Sandeep Singh, there are many people with this name. It's a very common name in India. And so good example will be to use something like SNDP, SNGH. Because if I Google this, most probably nothing will come. So that's how you name your concept. It has to be unique enough for the model. Okay, how you select your images. This talk is not that long, otherwise I would have done demo. But feel free to ping me after this talk, and I can walk you more and direct you to more concrete resources. I would love to. But this is the tool basically where you upload your images and convert them in like 512 by 512, all to be the same size, because Dreambooth API, which you use to fine tune, basically needs images in the same shape. And in fact, there is a requirement that you should try to have diverse background, diverse clothing, and lighting conditions and so on. So it will understand how your dog or particular subject which you're trying to train looks in different settings, and that's how it learns the concept. And this is the tool where you can upload your images, and this is the screenshot for that. It's very easy. And also it tells that whatever concept name you choose, just try to use the naming like this, like whatever unique token underscore with these numbers. Underscore is optional, but these numbering, it tells that these files of the same concept again and again, and this requirement comes from the Dreambooth library. Okay, if you really want to try yourself generating the images, you should go to RunPod, and there something called RunPod Fast Stable Diffusion. You select this image and continue and deploy it, and you can open the notebook there, and there is a notebook called Dreambooth V1, I believe, and you open it and run from top to bottom. It will give you sufficient examples how to generate and how. It's like you don't have to know anything about to use it. It's pretty self-explanatory. So just go to RunPod, select this image, create your image, and try to run notebooks provided there. If you're not able to do that, ping me on LinkedIn. I'll be more than happy to help you. You can find me at Sandeep Singh, Beans.AI. Probably I'll be the first person. But this is a good place where you can go and generate your images. Okay, so this is the example which I really wanted to show you. So there is a kid. These are the images of the kid, which we want to introduce concept. So it must be explicitly captioned for the model to differentiate the concept. So what I'm trying to say, suppose if I have some name XYZ for this kid, and if I train images of this kid, so do you see something different about these images? And that is that all of them have hat. So what happens if you just, and we as a human, we know the concept of hat is different from the kid. And if you're a painter, somebody asks, can you paint the photo of that kid? You'll paint it and probably you'll not remember the hat. You will remove the hat. But until somebody explicitly asks it. So what happens when you're choosing your images, make sure if it has some explicit concept, you write that concept explicitly in the caption of those images. So what you do, you give the images and you give the caption for that images, and it learns what the concept is, and accordingly it will try to generate it. So for example, if I just train without explicit caption saying some name wearing hat, it will assume that this person or kid always wears hats. So when you generate images, hat will always be there. So maybe you should write some token wearing hat, and explicitly know that the main concept is this and hat is auxiliary concept there when you select your data site. Okay, so many images have hat. That will become inherent part of token being trained. So you just have to give the explicit labels for that. So for example, if I have this unique token, if a train token, whatever, then following prompt might be this token smiling. Otherwise, when you generate the images, all the images he'll be smiling and wearing hat, something like that. Though we have not asked for hat, but all generated images have hat as inherent part of that particular token. So this is the conceptual understanding, how you select your images. Because there are a lot of free, if you go and search Dreambooth online free, there's many places where you can upload your images and generate your own concepts. But make sure you select the images which are diverse, and if they have explicit concept, you provide that concept in the text. Okay, so this is the good example. You will say particular token, smiling and wearing hat. Right? So it will know the main person is this. He is smiling, and that activity of smiling is not the inherent part of the kid, but it should be. Why not? And there is a hat, right? So that's how you create the label. And this is the slide which I want you to. So what happens? There will be people using the term Dreambooth and Stable Diffusion interchangeably. But there is a different purpose to each of them. For example, Dreambooth is used to generate personalized images of specific person, animal, or object, while Stable Diffusion is general technology using which you can generate images. It's not about customizing. Training data for Dreambooth, the example which I have shown you, the kid one, I just used 25 images. And that was sufficient to learn how he looks, and I can generate any image for him. And imagine the possibilities, the apps which you can create, right? You can just, every person you know can be customized, and you can generate anything in any setting, hopefully ethically, to do amazing. For example, if you want to wish somebody his birthday wish, and you want him to be sitting on an elephant, why not, right? Celebrating his birthday, or being on the beach, or whatever you can imagine. So Dreambooth is about customization. Stable Diffusion is generic generation of the images. Very less training data, almost like 25 images, which is nothing. Stable Diffusion, it requires a lot of images and a lot of compute as well. As I was telling, Stability.ai, Mostak's company, they spent $600,000 just to do the V1, and they released it for free. But within 6 weeks of, I believe, a month or so, 2 months, when they released the open source model to community, they became such a big deal. And within 2 months, they raised $110 million. There's a company called Stability.ai. They generated model using 600,000 or so money for V1, and they released it for free. But that created so much ripples for them. They raised around more than $100 million in 2 months. So that was a very good investment, I would say. In fact, as a matter of fact, the person who did that Stability.ai, Mustaq, he comes from the hedge fund, so he knows how it works. Okay. So, and Dreambooth is openly available. Stable Diffusion, it is available openly as well from Stability.ai, but there are a lot of closed source implementation like Imagen and DALI. We don't have access to their code. So to a large extent, it's open and closed both, but while Dreambooth is open source. So if you have never tried Dreambooth, I highly encourage you to go and try it out. There are links in this presentation, and you should give it a shot. And if you really feel, oh, I got the generic concept, but I don't know what to do next, just reach me on LinkedIn. I would love to help you. Fortunately, we are a very cozy audience, so not many of us. Okay. Okay. And that's it from my side. I hope it was not. So what I've done, I've purposefully gleamed over some complex concept because I wanted you to understand the intuition of this thing for sure. Because details are all gory and mathematical, but concept is what we talked about. So thanks for coming. It was lovely making a trip to do this. Thank you.